We have one more talk before the poster session, and I just want to quickly just say that international partnership, you heard it this morning, is a major part of CERVI, and we have seen a lot of collaborations with international partners throughout the years with CERVI. 17% of our publications since the inception of CERVI itself are with international collaborations. And so we were very excited. Many of you may have been there last year at the signing with Japan and CERVI and NASA. Dr. Lori Glaze partook in that, along with Dr. Masaki Fujimoto, who's going to speak to us now about Hayabusa 2 and the MMX missions. So please welcome him with me, and then we'll jump into the posters and/or discussion session after that. Masaki, are you here? No?
Yes, I hope we can see my slide.
We can see your slides and we can hear you, so take it away.
Okay, good. Thank you. So Hayabusa 2 is an asteroid sample return mission. It has been exploring one of the primordial asteroid Ryugu. It has made 2 touchdowns on its surface, and the second touchdown was after an impact experiment that excavated the subsurface samples, so that we think we got some subsurface samples sampled in the second touchdown. Departure from Ryugu was in November last year, and so it's heading towards Earth, returning to Earth. And landing in Australia will happen in December this year. So it's about half a year from now. So I think it's the right time to talk about how we will handle the samples after we recover the capsule from the desert in Australia. So that's what I'm going to talk about today. So after recovering the re-entry sample, what we will do is to, of course, secure the safety first, like removing the battery and the electronic boxes, and then do some cleaning. And then the first thing we do in Australia is to sample gas from inside a container. Well, Ryugu is a primordial asteroid, so there's some expectation that the gas may be inside a container, and we make sure that we get them before losing them during the transport back to Japan. So we're gonna build this kind of quick look facility at the site, and then get the gas samples if anything is available. And then by a private jet, we will transfer the sample capsule back to Japan, and then bring it to our curation facility in Japan, in the suburbs of Tokyo. And then what we will do is to remove all those, all those things that's surrounding the core part of the container. And then the core part of the container will be transferred to the clean chamber at the curation facility. So this photo shows the machine. This is the machine with which we will curate the samples, with which we will get the samples out of the sample container. First, we will open the sample container in vacuum, and then recover and curate some of the samples in vacuum forever. But that's not an easy process. So instead of having all of them handled in vacuum, under vacuum, we will move most of the samples to a chamber under purified nitrogen atmosphere. And then under those purified nitrogen atmosphere, we will manipulate samples of various sizes. And what this slide is showing is that a millimeter size sample, a millimeter size particle is like a ballpark number to show what the sample size will look like for this mission. And the total amount of sample is expected to be about 1 gram-ish, but that's something we don't know yet. We'll have to see until when we open the sample container. So this is a plan. December, we will recover the capsule back from Australia, and then the curation starts. And in about a half a year, we should be ready to do the initial analysis or preliminary examination, which will last for about a year. And then around 2 years from now, we should know that the result from the initial analysis should be able to tell us the high science potential of Ryugu samples returned by Hayabusa 2. So initial samples, you have to wait about a year until we know we have the showcase for the science potential of the samples that will consume about 50% of the returned samples. But then in June 2022, 2 years from now on, the science opportunity will be open to the international communities. We will issue the first international AO for sample analysis, and then I think, at some frequency, our AO will be issued on and on and on, so that our friends all over the world can have the opportunity to analyze the samples. So what I have to tell you now is that we already have a very high expectation of the samples, of the high science potential of the samples, because remote sensing observations already tell that the Ryugu sample seems to be much darker and looks very flaky, if I'm using the right word, flaky, which means that it's just unlike any meteorite that's available on the ground now. So the expectation here is that we're gonna analyze the sample that no one has ever analyzed before. And I think in 2 years from now, that kind of science opportunity will be available for everybody on this planet. But at this stage, you might be wondering that it's December that we will get the samples back. We will get the return of the sample capsule back. But before talking about that capsule recovery operation, I'd like to tell you the comparison between the HABS first and this HABS 2, the second one. So this photograph shows you the capsule reentry for the HABS first, which happened about 10 years from now. You can see the capsule returning, and you can see that the spacecraft itself is burning in the air. But for HABS 2, this is the plan. It's going to be different. So you can see the capsule returning back to Australia, but the spacecraft itself will fly by Earth. It will not dive into the atmosphere of Earth, so it will not burn out in the air, but instead it will make a flyby, and then the plan is to have an extended mission. So it's going to be a long mission though, but still the plan is to make it rendezvous with small 10-meter size near-Earth asteroid. So the extended mission will have a planetary defense flavor. And because of this small target asteroid is a fast spinner, it's going to bring us some new science as well. So extended mission, it will take some time, like 10 years until we get to the new target. But once we get to the new target, I think HABS 2 will accomplish its second objectives of its life. And then, but again, as I told you, this capsule recovery operation will take place in December. And who knows if the pandemic will be over by then. Well, I think not many people believe that it will be over by then, but in any case, we have to do this. If we don't do this, we just miss it. So we have to do this. And by itself, it's a lot of work, but under this COVID-19 pandemic, there's a lot more work we have to go through, but we are determined to do so. Like we will charter a flight to send the team into Australia. We will accept the 14 days quarantine before we can start anything related to the operation. The team will be composed of 80 people, and 80 people quarantine for 14 days seems like a headache, but still we are ready to accept it. And then we have to do all the operation under the social distancing, and that's another headache, but we're determined to do so. And we just have to do this, and I think we can do this because we already have a good plan to do this under this weird circumstance. So that's about HABS 2. And then I want to tell you something about another sample return mission, MMX. It's a Phobos sample return mission. we had an official approval in February this year, so that's very good. And the expected amount of sample from Phobos will be like 10 gram-ish. So it's an order of magnitude larger than HABS-2. So, well, the first target science is to understand the origin of Phobos. So based on that, on this science theme, people have thought about what they should do with the sample. So this is like the chart showing how they have thought through, assuming that this is a small body sample return mission. But on the other hand, because ejecta from Martian surface could have been showering the surface of Phobos for a long time, throughout the history of Mars, we can expect to collect Martian samples from the surface of Phobos. So this MMX mission has a flavor of poor Mars sample return mission. So this is another perspective that let the sample scientists think about what this mission should be and how they should handle the samples after the samples been returned.
Masaki,
And
2 more minutes, please.
Yes, and indeed, we have two sampling systems. One is a Cora that will access fresh subsurface materials provided from Japan. And another sampler is a pneumatic sampler that will mainly collect samples from the surface of Phobos. And if you think about the Martian samples, the pneumatic sampler, the sampler from the US, may collect more Martian samples than the Japanese sampler. So, well, it's good to have friends so that we can be we can meet the goal of two purposes. I mean two perspectives. So anyway, oh, by the way, then you might wonder what about the planetary protection issue? We have gone through the argument, and then the MMX mission is categorized as unrestricted Earth return mission, in case you are interested. And then, so the planning is going on. Planning of sample handling from MMX is moving on. And I think the scientists are really enjoying the discussion. But there will be, for sure, benefit a lot from experience with HABS-2 samples. And that campaign will start in half a year from now. So thank you very much.
Thank you very much. We have time for a question, and then we can move into the discussion session. I'm not seeing any hands raised. And I did see, so up here's one. Question from Camilo. Why will samples be handled in purified N2? What are the pros and cons versus other gases, e.g. inert or vacuum? Masaki, did you hear that?
Yes.
Okay. Yep.
On the other hand, because organic chemistry can be one of the pillars of HABS-2 sample analysis, some people worry about the isotopic, there might be some contamination to the isotopic analysis. So that's one thing we really have to be careful in doing the sample analysis.
Okay, it did cut out for a moment, but I think maybe you could talk with her or him again. Pascal, why don't you go ahead and unmute, and you can ask your question, and then we can finish up with this main part of the session.
Hello, Masaki. Do you hear me, everybody?
Yes, thank you.
Yeah, thank you for the talk. In fact, every talk today. But any update on MMX flyby plans at Deimos?
No, we're not there yet. I'm sorry. Because now we're making the detailed design of the spacecraft and the, mass resources and fuel allocation. There's going to be a trade-off between how much you want to spend your resources in like low altitude orbiting around Phobos versus flyby of the, more detailed flyby of Deimos. So we're not there yet, but well, the short answer is that we're not there yet.
Okay. So is this something you might decide only after or once you are at Phobos?
I think so. I have to ask the project manager for details, but they're really focusing on the low altitude campaign around Phobos now.
Yeah, of course. All right. Thank you.